Welcome back to Low Stress Math with Mrs. Bono. And today we're on lesson number 4 in chapter 3 or unit 3, depending on what I decided to call it today, equations. So this is more translation of equations. So here we go, more translation and solving equations. And I ran out of line. I gotta make longer lines. All right, so the warm-up is a warm-up. I want you to stop the video and try the problems and check them, because that's what that says, check over there. All right, I really think that you should have tried the problems, because the only way to get better at math is to do math. But now I'm going to solve them for you. Let's start with that first problem. It's a simple two-step equation. So here we go. 4x plus 6 equals 14. Okay, remember, we're doing reverse order of operations, so we're going to subtract 6 from both sides. Minus 6, minus 6. All right, let's see. Plus 6 minus 6 is 0. And I've run out of space, so I have to come over here. 4x equals 14 minus 6, 8. Okay. Divide by 4. Divide by 4. X equals 2. Okay. That is pretty much a basic two-step equation. So now I have to take my answer and I have to put it back into the original problem and check it. 4 parentheses 2, because I'm multiplying, that's what a number next to a variable means. 4 times 2 plus 6 equals 14. Okay. Hey Siri, what's 4 times 2 plus 6?
4 times 2 plus 6 is 14.
Oh, look at that. It worked. 4 times 2 plus 6 is 14. So 14 equals 14. Oh, did I cheat when I used my friend Siri? Not really. It's the same as using a calculator. It's only to check your work. You should be able to do the problems, but sometimes you've got to check your work. You might as well use every tool that you have. Sometimes I use photo math. It's all right. But you have to learn the steps to solving algebra problems. Let's look at this one. Look at this problem, negative p. See how there's so much nice space between the negative and the p? That's because it gave me room for my invisible 1. Negative 1p plus 7 equals negative 13. So, negative 1p plus 7 equals negative 13. All right, my inverse is to add 7 to both. Oh, wait, no. It says add 7, so I have to do the opposite. Subtract 7 from both sides. Let's see, negative 1 plus 7 minus 7 is, oh, I'm going to come right up here and do that same thing I did before. Negative 1p equals negative 13 minus 7 is negative 20. Now, that negative 1p means I have to divide by negative 1. Divide by negative 1, divide by negative 1, and I get p equals 20. And I'm going to check it. But this time I'm going to check it for real. I'm not going to mess around with my friend over there on the phone. Here we go. Negative, and instead of p, I'm going to put 20. Plus 7 equals negative 13. When the signs are different, you subtract. 20 minus 7 is 13. 20 is negative, so it's negative 13 equals negative 13. Yay, me. Okay, now the hard part. That has everything everyone hates about math. In other words, it's got fractions. And in order to add or subtract fractions, so if I want to move that fraction to the other side, I have to have a common denominator. So what I'm going to do is look at those numbers and I'm going to find the common denominator. So the least common denominator between 3 and 6 is 6. And I'm actually going to do it on some scrap paper so that I don't make a mess out of my real paper. And let's see, what do I have here? -4 thirds. And I wanted to have the common denominator 6. So I have to think to myself, all right, what times 3 gives me 6? Well, 3 times 2 is 6. But if you do it to the bottom, you have to do it to the top. -4 times 2 is -8. Now, if you've ever wondered, why am I allowed to do this with fractions? It's because, you know how 2 over 2 is actually equal to 1? Yeah, that's true, right? I'm going to put a little bubble of thought over here. 2 over 2 is equal to 1. And any number times 1 is equal to itself. So like 7 times 1 is 7, 43 times 1 is 43, 525,600 times 1 is equal to 525,600. Anything times 1 is itself. And that is an identity property. And that's why you can convert fractions. Because all you're really doing here is multiplying by 1. This is the exact same number as that. It's the same identity. They are very equal to each other. So now I have to do the other one. I have to do 2/3. So let's do that. Down here, 2/3, and I want it to be equal to something over 6. Again, identity property. 3 times 2 is 6. But if I do it to the bottom, I have to do it to the top. 2 times 2 is 4. So 2 over 2, that's 1. I'm multiplying by 1. So 2/3 is equal to 4 over 6. So now I can rewrite this problem, and instead of -4/3, I can use -8 over 6. And instead of 2/3, I can use 4 over 6. And then everybody has the same denominator. That's going to make this problem much, much easier to do. So let's take a look at this. -4/3 n is -8 over 6n minus, instead of 2/3, I'm going to use 4 over 6, and that is equal to 5 over 6. Voila. Everybody has the same denominator. And now is where I do the magic of math. Ooh, math magician. I am going to ignore the denominator altogether, and I am going to solve just the numerators. I'm going to solve the two-step equation, -8n minus, not 2, Bono, 4. Oh no, my whiteout. No, don't worry, it's right here. -8n minus 4 equals 5. All I did was take the numerators here. -8n minus 4 equals 5. When I have the same denominator on the bottom, I only have to deal with the numerators. Math magic. Plus 4 on both sides. And to get -8n equals 9. And I'm going to divide by -8 on both sides. And now I know you're thinking, that's a weird answer you got there, Bono. N equals -9 over 8. That doesn't look like it's real, but trust me, it's going to work out just fine. I'm going to go back to my original problem with my original denominators, and instead of n, I'm going to put in parentheses -9 over 8. So here's my check. I had negative 4 over 3 n. But instead of n, I am going to put parentheses negative 9 over 8. Remember, parentheses mean multiply. That's why they're very important at this point, because, you know, it gets very confusing without them. So I'm multiplying, and I'm going to subtract 2/3, and I'm going to get 5/6. And I'm going to do that on my regular calculator, because this calculator shows fractions so much better. So it was negative 4/3, and it's not even showing, there you go, negative 4/3 times negative 9 over 8 minus 2/3. And believe it or not, I got 5/6. And that means it checks. 5/6 equals 5/6. And it checks. Yay! And there was much rejoicing. All right, down here. Keys to success. When it says define your variables, this right here, that is where your let statement comes in. This is going to be your let statement. Define your variables means write a let statement. Right? Write an expression for each side of the equation. Well, let's just write an equation. Solve your equation. You know how to do that. Check your solution, the thing you never want to do but can save you a lot of problems in the future. Check your solution. Make sure you have answered the question. That's going to be really important too. So let's put some puffy cloud of thought around here, because these are the things that you should be thinking when you're solving a word problem. So here we go, some big thought bubbles down to a smiley, happy math student. All right, maybe not such a great looking math student, but that's what you should think. Okay, so for this first problem, I need a let statement. What letter do I want? I start with x, why not? Let x equal a number. So it starts with 2 times a number. That means you're going to multiply by 2. Decreased by 3 is 5. Okay, now I got to write myself an equation over here. 2 times x decreased by 3 is 5. All right, 2x minus 3 is 5. I'm going to add 3 to both sides. And negative 3 and positive 3 is 0. Bring down the 2x. Equals 5 plus 3 is 8. Okay. Inverse of multiply by 2, divide by 2 on both sides. 2 divided by 2 is 1. 8 divided by 2 is 4, so I get x equals 4. Yay! Much rejoicing. And now I just realized I have to check my solution. It says it right there. All right, so over here, I'm going to go my check. So 2, instead of x, 4, minus 3 equals 5. 2 times 4 is 8, minus 3 equals 5. 8 minus 3 is 5. It equals 5. It checks. Good. Now it's your turn. Try, translate, and solve the following 2 problems, A and B. Turn off the video, solve the problems, and come back. Don't worry, I'll be here when you get back. All right. I hope you tried the problems, because you know, only way to get better at math is to do math. And I am going to do these 2 problems. The sum. Sum means add. So sum of twice a number. Twice means multiply by 2. And 9 is 43. And also means add. So yeah, I'm just going to highlight that too. So I'm going to start with my let statement. Let's pick a different letter. Let n equal a number. I think I'm going to use some n's for a while. Why not? Let n equal a number. So sum means I'm going to be adding twice a number, 2n, and 9 is 43. Okay, 2n plus 9 is 43. All right. I am subtracting 9 from both sides, and I get 2n equals 43 minus 9, 34. Okay, the inverse of multiply by 2 is to divide by 2. All right, 2 divided by 2 is 1. 34 divided by 2 is 17. So n equals 17. Okay, now of course I have to check it because that's the rules. Check. 2 times 17 plus 9 is 43. 2 times 17 is 35 plus 9 is 43. 35 plus 9 is 43. It equals 43, so it checks. Yay! One more problem on this page. We're almost there. 8, oh gosh, less than after n. So that means you're going to switch it, and this 8 is going to go after the number. See, n for number, less than after n. So whatever this is, it's going to go after the n. And 1/2 is the same as divide by 2, and is, of course, is my equal sign. So let's just do this problem. Let n equal a number. All right, and 1/2 of a number, that's n divided by 2. N divided by 2. Less than 8 minus 8 is 2, equals 2. So now, add 8 to both sides. Let's see, -8 and +8 is 0. N divided by 2 equals 2 plus 8 is 10. Okay, the opposite of divide by 2, multiply by 2. So I'm going to multiply n times 2 and 10 times 2. 2 divided by 2 is 1, and 10 times 2, n equals 20. All right, now I just have to check that and see what I get. Check. 20 divided by 2 minus 8 is 2. 20 divided by 2 is 10, minus 8 is 2. 10 minus 8 is 2. It equals 2. It checks, and all the math is good on this page. Deep breath, because now, word problems. Now we have to translate real word problems. All right, first thing you do when you get a word problem is sigh, because it's a word problem. But then you just have to say, all right, I can read. A baseball bat and 8 baseballs cost $163.25. What, are you kidding me? All right, no, I'm good. The bat cost $106.45. What is the cost of 1 baseball? How do I know what my let statement is going to be? Because I know I'm translating this into a math problem. So I do have to start with a let statement. And how do I know what the let statement is going to be? Well, the way you figure that out is you look at the question part of it. The part that's down here that says, what is the cost of 1 baseball? That's going to be my let statement. Instead of what is, I'm going to say, let X, B, K, whatever, let X equal the cost of one baseball. Just copy it. The cost of one baseball. Yeah, it's not so bad. Now, I go back and read some more. A baseball bat and 8 baseballs. Well, that looks like addition to me. Cost $163.25. The baseball bat is $106.45. So the bat and the 8 balls, so one bat, $106.45, plus 8 baseballs equals $163.25. So I'm adding the price of the bat plus the 8 baseballs, $163.25. All right. Now, I want to get the variable by itself, so I'm going to subtract $106.45 from both sides, minus $106.45. And generally, this is where I pick up my calculator, because I don't want to be messing around with money and numbers and wishing I had my calculator when I have it right here. So let's clear that up and take a look at it. 163.25, double check that you put it in right, because that's where half the mistakes are made, minus 106.45 is 56.8. Okay, put that on the side now. This is 0. So now I know 8 baseballs is equal to 56.8. All right, but I don't want 8 baseballs. I only want to know the cost of one baseball. So I have to divide by 8 on both sides. And I get, well, 8 divided by 8 is 1. So one baseball is, come back, here we go. Divided by 8, 7.1. Oh, wait a second, that's not money. 7.1. The cost of one baseball is not 7.1. That's not money. In order to be money, I have to have 2 decimal places. So I need to add a 0 after the 1 and turn it into money. Ha! 7.10. That's money. So now I know the cost of one baseball is $7.10. There's my answer. Cost of one baseball. All right, Hugo received $100 for his birthday. Pfft, I'd like $100 for my birthday. Then saved $20 a week until he had a total of $460 to buy a printer. Wow, that's a lot. How many weeks does it take for him to save the money? Ah, here's my question. How many weeks? Right there. Now, the question is what's going to become the let statement. So how many weeks? How many is let x equal weeks? Does it take for him to say, I don't need to write all that. Let x equal weeks. All right, there's my let statement. Now, he saved, well, he got $100 for his birthday. So let's start with that. $100. Then he saved $20 per week. This word per, that's really telling you to multiply. So it's the $100 plus $20 per week times x until he had $460. All right. Key there is per, and he saved. So let's subtract 100 from both sides. And now, this is 0, and 20x equals 360. Okay. Now I have to divide by 20. And I get, well, let's see, I think it's 18. X equals, don't guess, Bono, use your calculator, check yourself. 360 divided by 20 is 18. There we go, 18. All right, 18 weeks. Okay, it takes him, I don't know what I was writing. I thought I was writing home. It takes him 18 weeks to save the money. All right, the next two problems are up to you. Solve them. You can do this. It's not that bad. The question is telling you what the let statement needs to be. And then just highlight and circle. You can do this. Take care. Bye.